Hello everyone. Today I will discuss the problem of a strength of material. So everyone also know that strength of material is like a design part or it is an analysis part of your civil department or civil engineering. So now will be discuss stress strain problem like that. This is the problem of the question is a rod 160 centimeter long and of the diameter 2 centimeter is subjected to an axial pull of 40 kilonewton if the modulus of elasticity of the material of the rod is 2 into 10 to the power 5 newton per mm square, then determine the stress strain and Young's modulus or elongation of the rod. Not a Young's modulus, elongation of the rod. So today I will be the it is the one type of problem part in your semester questions. So now we'll be discuss how to solve this problem. So first of all, first step is your to give your given data or to show your given data in this answer booklet. You show your first step given data. So now we'll be write it down in a given data. Hmm. Now in this time I will be say that the what is the given data in this question, what is the given in this question, what are the types of given data will be show off in this question. Now will be discussed. So first is your what, rod 160 centimeter long, that means given data. Okay, so now given data. First is your length L equal to 160 centimeter. What? 160 centimeter. Diameter of the rod. What? Now diameter of the rod. Diameter of the rod. What? 2 centimeter. That to be 20 mm. 2 centimeter will be converted that millimeter 20 mm. Right. Now we'll be calculate area of the rod. Area. Formula is your pi by 4 into d square. Then pi by 4 into d is your what? Diameter of the rod. 20 20 of square. Now will be given in your calculator. It is like a electric calculator. What is the digital calculator? In this calculator will be solve that, or it is will be calculate that these situations, these equations. Now shift pi by 4 into 20 square. What is this? What is the amount of pi by 4 into 20 square? 314.15, right? And this mm square, this is the unit, right? Then uh, what is the what are the determination, like what is the in this problem, how could you calculate the questions, stress strain and elongation of the rod. And in this time equations, in this time also another given data is your E, capital E equal to what, elasticity or modulus of elasticity 2 into 10 to the power 5 Newton per mm square. Okay. Now axial pull, in this question also given data is a axial pull. That means load P equal to what, 40 kilo Newton. This is the 40 kilo Newton. Then 40 kilo Newton, how could you Newton will be converted in a Newton? 40,000 Newton. right? Then also E also given in this question, and now will be calculate P. Then calculate then the formula of stress. First bit is your the stress, right? The stress formula, the stress of formula, it is also denoted by sigma. Then sigma equal to P by A, right? P is your load, that means 40,000, right, Newton per. A is your what? 314.15 mm square. And also know that sigma, that means stress of unit is Newton per mm square. Now will be calculate 40,000 divided by 314.15, 126.98 या 127, 127.32. That to be will be it is a round of figure is a 127, because in a point after decimal is a 3, so that 127 after 5 and 5 above of a decimal, then will be so that 128, right? Now this is the unit always given in your unit. So in a stress unit is what? Newton per mm square. So now will be write it down, Newton per mm square. Okay. Now second bit your what? Strain. The strain. That means strain is your what? How to could you calculate in your strain? So capital E, that means Young's of modulus या modulus of elasticity, E equal to sigma by small e, right? Then sigma by small e I also calculate in your E. Then E equal to sigma by capital E, right? Now in your what is the sigma? 127, that is a sigma, and capital is a 2 into 10 to the power 5, right? The answer is your calculate 127 divided by 2 into 10 to the power 5, right? Answer is your 6.35 into 10 to the power minus 4, and it is also calculate that 0.000635. And strain also is a what unit? Unitless. So in this time unit is not a given, or not will be so that in this strain value. Then after that all are will be calculate Young's modulus of the rod. Now will be calculate third point is your elongation. That means elongation. Elongation in the sense, third bit is your elongation. Elongation. Elongation in the sense small e equal to del L by capital L. Now will be calculate what? Del L. Del L is your elongation. Del L equal to small e into capital L. Small e value is your what? Now in this time will be calculate small e value what? 0.000635, right? So will be calculate 0.000635 into L is your what? 160. Now will be calculate E value 0.000635 into 160. Answer is your 0.1016 centimeter. This is the answer. All are hope so understood. uh, Again, फिर से I will also repeat this question. So this question is also given in your given data is your length, then diameter, then your modulus of elasticity, then what, the and load also, axial pull load. So now will be calculate area of the road, pi by 4 into d square, pi by 4 into d is a 20. So now will be calculate, now will be solve that this equations is a 314.15 mm square. Now I also know that axial load will be given that in your question 40 kilonewton. So kilonewton will be converted that into newton, 40,000, 40,000 newton, right? Now will we calculate the question of this, what is the determination, or what is the in this question how could we calculate, what is the calculate, or what is the form will be calculate stress, strain and elongation of the rod. So now will be calculate stress. Stress is a formula sigma equal to p by a. P is a 40,000 newton divided by a, also calculated in a 314.15. The 4.15 also show in this equation. So sigma equal to in this formula, this is a like put the formula and get the answer. So p by a is your total all over we calculate, answer is your 127.32, and it is a randomly or it is a round of value 127 newton per mm square, because stress will be given there, so that in this unit newton per mm square, right? Then after that, what is the strain? Then strain formula is a capital E equal to sigma by E. Then small e is also strain. So small e equal to sigma by capital E. Now also know that sigma is a 127 and E capital E also given that modulus of elasticity 2 into 10 to the power 5. So now it will be calculate 6.35 into 10 to the power minus 1, and it is also calculate all overall 0.000635. Okay. Now, and this is the last bit, elongation. Elongation in the sense small e, it is small e equal to del L by capital L. Del L is the elongation area and capital L is the original area. So del L equal to E into capital L. E also value is a 0.000635 into L also given that 160. So now calculate this value 0.1016 centimeter. So hope so ऑल ऑफ यू अंडरस्टूड दिस क्वेश्चंस. थैंक यू सो मच. एंड अगर आप लोगों को इस वीडियो में कोई भी प्रॉब्लम हुआ, देन यू कैन बी सी दैट, और प्लीज़ कमेंट योर कमेंट बॉक्स. थैंक यू सो मच. कीप योर ब्लेस. थैंक यू सो मच.